So this is the setup I've done for the Z-axis to measure the shift of the axis of the motor after a certain amount of rounds, around 5 minutes to run, then we'll see the shift. I've done a test file out of this model. It's basically the circle with this millet holes on a edge of it. So it's perfectly showing that after 5 minutes of doing this, I will run a dry run of it, and it starts going up on the model. You see, it goes upper, and then stop processing the model at all. So the mill goes above the model after some time. So here I've run the model. It's doing the circle and then moving the Z-axis. So you see it's doing circle by circle, almost at the same route, the same path. And it's just moving the Z-axis there and back, and then return back to the circle again. This is how Z-axis working. So as you can see, the program itself is just relatively shifting the coordinates, and then on a certain points just lowering Z and returning back to 0. So it's relative coordinates all the time. Also, which is interesting, I run another testing program which is not touching X and Y. Just two axes stay at the same place, just moving the Z, and after 5 minutes of run it's not showing any discrepancy, so the motor returns back to perfectly exactly the same value point as it should be. But when I move to the program when it's moving X and X and Y axis, then the discrepancies start appearing. So as you can see here, it's moving X and Y axis, and it starts producing the error. All axes and metal parts oiled, so it's moving freely, absolutely. So there should be any basically interactions with the Z. So 5 minutes of run, the program is stopped. As you may see, it should stop and the Z0 relative, and it's actually 0 on a Z axis. It's not 0 on a X and the Y, but doesn't really matter. The Z should be 0. And this is what we get with this axis set. So it's basically almost one full step upper than it should be. So it stopped at this position, and it should be closer to the mark we've done. So that's the problem.